Hello and welcome. In this video, I'm going to complete a series of tasks for MPLS on OcNOS routers. So first of all, I'm going to speak about the task itself that says provide IPv6 connectivity. This one is important, and it says that between ABC branches using 6BPE technology. So what we are trying to say is we need to enable 6BPE in our network, and this is assuming that our network doesn't have any kind of IPv6 configuration for now, which means that our network is going to be pure IPv4. And what we have here are two customers, or maybe two parts of our network, our enterprise, which are running IPv6 for some reason. Let's say, for example, there is an application here that has IPv6 capabilities, and we need to provide connection between the two, let's say, instance of this application for my customer. Here we have IPv6 as well. Maybe we have IPv4 as well. I don't really care, but IPv6 is going to be the important thing. So what we are trying to say is this IPv6 traffic should be able to traverse our IPv4 network to the other side, which again means that we need to create kind of a tunnel in here to, transfer the communication. And that tunnel is going to be between the two PEs. And this tunnel is going to be of type VPN v6, which I'm going to configure this. Let's say that in the beginning, we should have something like a VPN v4 connectivity, which we are going to do this because I'm going to do every piece of configuration from scratch. The only thing that right now I have is OSPF inside my service provider as my IGP. Okay, so the overall intent is to tunnel IPv6 communication through IPv4 network, and there are different types of technologies. You can just go with a simple tunnel here, such as a GRE tunnel. You can go with MPLS, as we are going to do here using VPN v6, and enable 6BPE. You can go with 6PE without even having to have something like this. There are different things that we can do here, but in the task specifically, we are asked to configure 6BPE, which is what we are going to do in this task. Okay, so what I'm trying to do is this. Everything is going to happen inside my service provider. My customer doesn't have anything other than a BGP connection here. Maybe this is BGP. You can just go with other types of protocol, but I assume that there is a BGP neighborship between different branches. And just for the sake of simplicity, I'm not going to use the same AS. If you go with the same AS, you need to allow AS in on the branches or AS override on the service provider. But let's say that ABC is going to be AS 650, ABC on the other side is going to be 651, and let's say that my service provider is going to be Autonomous System 100. So this is the overall configuration. Inside my service provider, there are technologies that I need to enable. One of them is going to be MPLS, and for that, the only thing that I need is to go with label switching command on this interfaces, which are going to be inside my network. This is going to be a provider router, this is going to be a provider edge router, and also this one is going to be provider edge router. Provider router is going to have very simple configuration. We are not going to do a lot of things on that. The only thing that we need to do is to configure MPLS. And also for label switching, I'm going to go with LDP. You can go with segment routing as well, or maybe even RSVP. But here, of course, MPLS is going to be there and LDP is going to be enabled. Something that some people like to do is to create LDP adjacency between router 2 and router 3 as a remote LDP connection. In my case, of course, it's not going to be necessary, but we can do it. Whatever that we want is going to be possible in this configuration. So that's going to be the technologies that we need to enable here. So I guess we should start the configuration from our customers. Maybe is going to be easier. So let's do this and then get back to the service provider and do everything there. So my customer router ABC router 1, let's just connect to that. So what I'm going to say is, for now there is an end-to-end connection from router 1 to router 6, but I'm going to remove what we have here. So I'm going to say no router OSPF1, and this is going to be committed. So what I'm going to say is router BGP 650, and I can say BGP router ID is going to be 1111, and then I have an adjacency here, but the adjacency is going to be of type IPv6. So what I'm going to say is neighbor 2001, and let's say that this is going to be 10.151. So that's going to be 2001 10.151, and double colon, that's going to be 1. It's going to be in remote AS 100, and for router 1 everything is going to be a simple IPv6 unicast address family, and this neighbor is going to be activated. And also I'm going to advertise my network, which is going to be 2000 double colon 1/128. And of course I can just advertise the connected networks here. We can do that, redistribute connected, and that's okay. So for my interface loopback, I'm going to have an IPv6 address of 2000 double colon 1/128. We don't need to specify secondary because IPv6 addresses could be configured as many as them as you wish. And also the interface which is connected here is going to be ETH, not ETH, as a matter of fact, XE4.151, and it's going to have an IPv6 address of 2001 10.151 double colon 1, and I guess I have made a mistake here in this neighbor configuration, which I'm going to fix it in a second, no worries. So I'm going to say IPv6 address is configured like this. So let's just say commit and then fix the problem. So if I just say show run router BGP, what I needed to say is that the other side is router 2, so I should have gone with that. So let's say that router BGP 650, and I would say no neighbor this, but neighbor should be 2 as a matter of fact. So that should be 2, and then address family IPv6 unicast, and then this neighbor is going to be activated. Okay, now we fixed the problem. Okay, so this side is done. Nothing special about this one. So I'm going to just save the configuration. Let's do the other side, which is router 6. And for router 6, I'm going to say enable commit configuration. No router OSPF1. I'm going to say interface loopback. IPv6 address is going to be 2000 double colon 6/128, and then I'm going to have interface XE4.154, I believe. Let's see. Yes, this is 154. And going back to here, I'm going to assign an IPv6 address of 2001, and that is going to be 10.154 and double colon 6 here /64. Okay, now I'm going to configure BGP here, router BGP 651, router BGP 651, and then router ID or BGP router ID is going to be 6666. My neighbor is going to be 2001 10.154, and I guess this is 3. Let me see. Yes, that's 3. and that is going to be in remote AS 100, address family IPv6 unicast. It's going to have this activated. Okay, so this side, of course, let me just advertise some network as well. So network is going to be 2000 6/128, and also let's redistribute to connected networks. Okay, so let's commit the configuration. So customer side, everything seems to be okay and nothing special about that. So save it. Let's go to service provider, and I'm going to start from router 2. On each one of these routers, I'm going to complete the configuration so that you can see what we really need. Okay, so on router 2, the first thing that I want to do is to say that there is an IPv6 address configured for this interface, but this is under a VRF. So I'm going to configure a VRF for my ABC. So let's just configure that. So first thing that I'm going to say is IPVRF ABC. That's the name of this. And this VRF is going to have a route distinguisher, which is going to be RD value. And let's say it is 1616. And then I'm going to have a route target for both of 1616. I'm just making everything super simple. Okay, so the interface is going to be show run interface XE, that is 4.151. So this is going to go on their VRF. So what I'm going to say is this interface. Then I'm going to say IP VRF forwarding is going to be ABC. This is going to lose its IP address, so I need to assign the IP address as well. And also I'm going to have an IPv6 address because this is the only interface on router 2 which needs an IPv6 address because it is connected to my ABC. So you can see that I'm trying to change my network, but super minimal changes are going to be applied. I'm not trying to disrupt the network completely. I just try to assign as little changes, apply as little changes as possible to my network. So IPv6 address is going to be 2001.10.151:1/64. That's it. So I created this VRF, and let's say I'm committing this. And now that I have, let's see, it says that duplicate address was detected. Let me see. So if I say just show run interface XE4.151, it says that IPv6 address is not assigned on router 1. If I just say okay, I know what the problem might be. Show run interface XE4.151. Okay, so this is the IP address that we assigned on this side, so we should not be having any problem on router 2. So if I just go to interface XE4.151, the IP address should be assigned again. So this should be here, and I'm going to commit this. And also IPv6 address should be 2001.10.151:2/64, and then commit this as well. Okay, so now we have no problem in configuration. So if I just say do show run interface XE4.151, you should see that everything seems to be good. And if I try to ping the other side, I could say do ping IPv6, and I'm going to say VRF is going to be ABC, and this is the IPv6 address, which is 1. And here, of course, I should say VRF ABC later. IPv6 and then VRF ABC. So you see that the ping is going through without any problem. The same thing should be done on router 3, which is the other PE, but let's do this later. Okay, now that I have created this, what I need to do is to create a BGP connection to ABC as well. So what I'm going to say is router BGP 100, and if I just go to router 1, this is correctly set. Okay, I'm going to say BGP router ID is going to be 2222, and then I'm going to say neighbor to, of course, this could go under BGP. Yes, let's just do this. 2001, 10, 151, and 1 is in remote AS 650. And we are going to go with this address family IPv6. And because this is under a VRF, I'm going to say VRF ABC. And this is going to be activated. Okay, so let's just commit the configuration. And this part is going to be done. And here there is a problem. Let's say what the problem might be. Here it says that so specify remote. Oh, it says that everything should go under VRF. Yes, of course. Of course it should go under VRF. So what I'm going to do is to say this here. And then I'm going to say commit. And here, of course, let's just show current transaction using this. So this should be gone. So if I just here router BGP 100, no of this, then commit this. Okay, so now we should, again, let's see, show transaction current says that, okay, let's just do this. I'm going to say abort transaction. Then I'm going to start the configuration again, which is going to be simpler. Because sometimes when you try to do something like this is going to give you some errors. Here what it says is this. It says specify remote AS peer group remote AS first. What did I do then? So if I say show transaction current, everything seems to be good. But okay, let's do this one more time. Abort tran. Sometimes you're receiving some problems like this. Then you need to just go with the correct order, and then you are not going to receive any error. So you see that the first command says activate, the second one says remote AS, and the operating system just needs the first one to be this one. Okay, so if I just say do show IP v6 BGP summary, of course this is not going to give you complete information about the neighbor, but at least it says that there is this configuration, and it has just created the connection between these two. Okay, so we have this, and now you can see that the two prefixes has been received. Next thing that I'm going to do is to enable MPLS and also LDP as the protocol for labeling. And I need to do this on internal service provider interfaces. In my case, on router 2, that's going to be XE4.152. So let's do this. First of all, I'm going to say router LDP. And under this, I'm going to say transport address is going to be 2222. I could transport address IPv4, I believe. IPv4, yes, that's correct. And then I'm going to exit this. You can create a targeted peer between router 2 and router 3, which are my Ps, but I guess the physical peer is going to be okay as well. So let's see interface XA4.152. which is the interface. I'm going to say label switching for MPLS, and I'm going to say enable LDP IPv4. That's it. So this is going to enable LDP on here. We don't need to do anything for the loopback interface, so I'm just going to say commit and end for now and save it. Okay, so let's take a look at the running configuration. Hopefully everything is in place. So we have this ABC VRF that we have created. If I just go down a little bit, there are some configuration from previous labs. That's okay. These are for QoS. And if I just go to loopback, you can see this IP loopback is configured. And then if I just go down, you can see this interface 151 is under VRF ABC with IPv6 address configured, and that this 152, which refers to this interface, internal interface of the service provider, has this label switching and LDP enabled. And also what I have is this router OSPF configuration. I need to make some changes to this, and I'm going to do that in a second. And if I just go down, you can see that this router BGP is done. Okay, there's just one thing that I have not done, and I'm going to do it in a second. So let's just go to configuration. For router OSPF, I'm going to say passive interface XE4.151 enable. That is because I don't want this interface to be in OSPF. Of course, if it didn't do this, that wouldn't do anything for this, because this is now under VRF and this OSPF instance is not under a VRF. So that's okay. You can just ignore it. Now what I need to do is to say router BGP 100, and my neighbor is going to be 3333, which is in my remote AS, my AS as a matter of fact. And I'm using an update source of loopback, but because I might have multiple addresses for loopback, I'm just going to go with this specific IP address. So that would be 2222. Then I need to enable VPN v4 for this. So I'm going to say address family VPN v4 unicast. Under this network, this neighbor is going to be activated. So that is what we need. But now what we want to do is to say, okay, we are trying to have 6 VPE. So this means that VPN v6 should be enabled as well. That is super simple. What I need to say is just to change this to 6 and VPN address family. So I need to just exit this and then do this. Okay. And then activate that neighbor here as well. That's almost everything that I need to have. I can just say redistribute connected here. That would not hurt. Redistribute connected, this is not working, so that's okay. So just say commit. And for this address family IPv4 ABC, that's a good thing to say redistribute connected for this, not that one. So we have done it later, redistribute connected. We have done it on ABC, but that wouldn't hurt to do this here. So let's just commit this here and okay. One more time, show run, and seems everything to be in place without any problem. Okay, so the BGP configuration is something like that. Let's now go to router 4. Router 4 has a very minimal configuration. It doesn't have anything specific. Right now, OSPF is working on router 4. So if I just go to router 4 and say, do show IP OSPF neighbor, you can see that I have 2 neighbor, and I can just change the connections to point so that I don't have this DR and backup stuff here. That would be much better, and this is it would just reduce the size of my LSDB as well. But that's okay, no problem with that. The only thing that I want to say is show run, and I'm going to say interface loopback. Interface loopback is configured with 4444. I'm going to say router LDP, and transport address IPv4 should be 4444. I have two interfaces that I need to configure with MPLS, and just copy the commands from here. Simple. So my interfaces are going to be this interface XE4. First of all, I need to exit. Okay, so interface XE4.152. I need to have these commands, and 153. These commands. So that's it. Router 4 does not have any more configuration. Let me just show you the configuration of router 4. What do we have here? So here on router 4, the only thing that we have, these are from some other configuration that I have. They're not going to do anything with our configuration, so I'm not going to do anything with them. And this is loopback interface, and then I have these two interfaces that have label switching and LDP enabled on them, and I have my IGP configured here as well. That's it, and done. Now let's go to the other PE, which is going to be router 3, and most of the configuration for router 3 could be copied from router 2, which is simple. So let's go to that and do it. Okay, so let me just do something on all of these routers, because I do not really want to have them. This should not be a problem. Let's just close the switch. I don't really need it. And router 6, 3, 4. And I'm going to say end here and save the configuration. Router 2 and router 1. I just want to change their connection timeout. So let's just go to enable mode, then configuration mode, and then say line con 0 exec timeout is going to be a lot. Then commit, and then end and save everything. So this is done on all of these routers, so they are not going to just time out. Okay, so go to router 2 and say show run, just because we are going to copy a lot of things from here. So VRF is going to be created on router 3. So let's go to configuration mode. The same VRF configuration is going to be here. Exit. Then I need to go down a little bit. Let's go to interface configuration here. This one is going to be under VRF ABC. So let's go to router 3. And the interface is 10.10.154, which is going to be this one. Interface XE4.154. So if I just say show run interface, for now it says this, but right now I'm going to paste this here. Let's commit this first. It is going to lose its IP address. That's okay. We are going to assign the IP address and also an IPv6 address, which is going to be 2001, and that's going to be 10.154, and this is router 3/64, and I don't need any loopback IPv6 address. We are going to make sure that the configuration is going to have minimal effect on this router 3. The other piece of configuration that I need to have is this one on the internal interfaces. So that is going to be interface XE4.153. So MPLS is going to be enabled for this. And then I'm going to say router LDP. And then we are going to have transport address IPv4 as 3333. Then I'm going to commit this part of the configuration and exit, of course. Then let's go to router 2 and go down and see what else we have. We have router OSPF, that's okay. And we have router BGP. This is what we want to use it as a template. Going back to here, I'm going to paste it here and change something. So here router ID is going to be 3333. My neighbor is 2222. So I'm going to just copy this. And neighbor is going to be this. And the update source is going to be 3333. And my neighbor should be activated here for VPN v4 and for VPN v6. And then my neighbor on the other side is 154.6. 154.6, which is in 651. Okay, let's see everything is correct. 154.6, that's right. And my BGP configuration is going to look like this. Let's just copy this and go to router 3 and paste the configuration here and then commit. Okay, seems everything is done in here as well. We are going to take a look at the configuration again, but for now everything seems to be okay. Okay, now it is time for verification and see everything is working or not, and whether we have just forgotten to do any piece of configuration. Let's just take a look at the configuration first and then go for verification. So what did we do in here? We created a VPN v4 adjacency between router 2 and router 3. That is because we might have lots of different customers here. Let's say that, for example, ABC is not my only customer. I might have, let's say, this one, which is Globetrotter, and Globetrotter might have another branch on the other side. So this is going to have its own VRF. Maybe Globetrotter is an IPv4 neighbor customer, as a matter of fact. So what I need to do is to make sure that there is a VPN v4 connection there. Maybe I have another customer which is called Alex, and Alex has another branch on the other side as well, and they are connected to here. They are IPv4 as well. Maybe I have another neighbor which is, let's say, for example, Kenzo, and Kenzo again is an IPv4 customer here. So all of these are their IPv4 and they are connected using normal IPv4 connection, and inside we have VPN v4 neighborship between router 2 and router 3 to make sure that these are going to be reachable from both sides. But here ABC has come up with new requirements. ABC needs IPv6 connectivity. So what we need to do is everything outside is very similar to what we did previously for VPN for IPv4. All I need to have is going to be an IPv6 adjacency here. Because this is under VRF, I need to just make sure that my PE is using VRF. But here I need to have VPN v6 tunnel as well, because now I am just traversing some kind of VPN v6, some kind of IPv6 connection on IPv6 data, inside my network to the other side. So we said that VPN v4 should be there, VPN v6 should be there. We have MPLS using LDP here and here, MPLS and LDP inside my network. And the rest, of course, is super simple as you saw. Okay, so time for verification. So the first thing I'm going to do on router 2, maybe. On router 2, I'm going to say show IPBGP VPN v6 summary, or VPN v6 all summary. Hit enter. Okay, so let's just bring this in here. Okay, you can see that I have a VPN configured connection between router 3 and me, and I have some prefixes sent to the other side. And here, as you can see, there is an IPv6 configuration, normal IPv6 connection between me and my customer. So if I just say show IPVGP neighbor 3333, you can see that there are some capabilities that we have enabled. These two capabilities are VPN v4 and VPN v6, as you can see. And if I just go back to this command and just hit enter, you can see the prefixes that now are going through this neighbor to the other side. Specifically, these two prefixes are going to be important for us because these belong to my customers. Okay, so this means that we are doing everything correctly. Now let's go to router 1 and router 6. These are going, and also let me just do something here. I'm just going to say show LDP, MPLS LDP neighbor. You can see that my adjacency is there, and I'm going to do the same thing on router 4, which I expect to see 2 neighbors here, and on router 3, which I expect to see 1 neighbor here, which is correctly set. And if I just say show MPLS forwarding table, I should see that there are labels created for me, as you can see. But because we have only one provider router, most of the labels are going to be implicit null, which means that we are going to pop the label in that neighbor. Okay, so let's go to customer. On customer, if I just say show IP BGP and hit enter, we have nothing because we have not sent anything for IP. And if I say show IPv6 BGP, and after that, not IPv6 BGP, as a matter of fact, I should say show BGP IPv6, and after that, hit enter. Now you can see that I am receiving the prefixes. This prefix is from the other side, and I should be able to reach to there. I need to see this in my routing table, as a matter of fact. So if I say show IPv6 route, I see that prefix in my routing table. Now if I just say ping IPv6, and that is going to be this one, and I'm going to source this from my IPv6, you can see that I have connectivity, and my my configuration is working just fine. Okay, so everything is done. My configuration is done, and all the verification is working. There are some more verifications that you can just go with, but I believe that these are going to be enough just to check what is happening in our network. I hope this has been informative for you, and see you in next videos.